All right, guys, so welcome back. So I'll be solving some questions on electrolysis for you now, because I saw a question. I saw some past questions on it yesterday, so I decided to make a video. So the first question is: a current of 20 amps is passed for 30 minutes during the electrolysis of gold 3 tetraoxosulfate 6. The mass of gold deposited at the cathode is. So you have to know how know how to balance those reactions. So you have to know how to write those reactions. Now you have gold 3. So first of all, you write out your reaction: gold 3 plus 3e electron. And but because this is CBT, so this might not be necessary, but it's very good for you to have an idea of the amount of charge those things can deposit. Yeah. So the first thing for you to do, from the information you are being given, 20 amps of current is passed for 30 minutes. So that means you have to look for your Q, which is Q equals to IT. That's the amount of charge. So which is equals to 20 amps times 30 minutes. 30, it was given in a minute, so you convert it to seconds. That is times 60 equals 36,000. 36,000 coulomb. Now if I convert it to farad, it will be 36,000 over 96,500, because 1 Faraday is equals to 96,500 coulomb. So I converted it to farad because you might actually need it in another some cases. So now there are two methods you can use. You can use a formula and you can also use this method. Now, but let me use mole ratio method first. So when you have your reaction like this, you are going to say 3 Faraday, because we have 3 electrons here. So you see 3 Faraday deposits 1 mole. This place 1 mole, 3 Faraday. Then you now say okay. Then you now say okay, you have to calculate this. So as you can see, the Faraday, when I divided it, I got 0.373. So you now come back here and say 3 farad gives 1 mole. That is 3 farad here. And then 0.373 we deposit how many mole? 0.373 Faraday we deposit on x mole. So then you cross multiply. So you have 3x gives 0.373. Then you divide by 3. So you have x equals to, so you are going to have x equals to 0.124. So then 0.124 mole. So this is the mole. Now what you are going to do is, the formula for mass equals to what? Mole times molar mass. So then you say mole, which is 0.124, times the molar mass according to the information given in the question. It said molar mass of gold is what? Is equals to 197 197 kilogram per kilomole. So right, according to what was given in the question, this is the molar mass. So then you multiply it by 197. So you are going to get what? You are going to get 24.49 gram. So now let's use the formula method. Now the formula to also solve this, well, I will advise that you go with the one that is faster for you, so and easiest for you. So we have mass over molar mass. I will write molar mass as capital letter M, big M, equals to quantity of electricity over amount of charge over N times what? Times F. This F is Faraday's constant, that is 96,500. This Q is the amount of charge, which is amount of charge, which is Q equals IT, and then N equals to what? Number of charge on that substance. So Now the mass is what we are looking for, so you continue as mass over the molar mass is 197 equals to the charge Q equals to IT. We've already solved it up here, so you have Q to be 36,000, so over the amount of charge on gold is 3. This is the amount of charge here, so you write 3 times, then F here is 96,500, so you divide. You can see that this one is faster, so you can actually go for this. M times 3 times 96,500 equals to 3600 times 197. So after solving, I have M equals to what? M equals to what? Equals to 24.49. So the same thing as what I got here in this place. So alright guys, so the next question says that a quantity of electricity liberated 1.50 gram of aluminum from its ore. The mass of copper that will be liberated by the same quantity of electricity is what? So so now the question is that what amount of copper will be liberated by the same quantity of electricity that liberates 1.5 gram of aluminum. So now first of all, we first have to know the quantity of electricity that liberates aluminum. So as I said earlier, there are two methods to doing this. So you can use the mole ratio method, like the relationship method, and the formula method, but I'll show you the two. So although I have a particular problem with this question because I didn't actually see the answer in the options, but I believe strongly that this is the way that it should be solved. So these are the additional information. Copper 64, that is the molar mass, and then Faraday is this. And then so you start with, since you are given 1.5 gram of aluminum that is being deposited on the cathode, so you are going to look for the mole, because we'll be needing the mole. That is mole equals mass over molar mass equals to this, which equals to 0.056. So then you write out the reaction for aluminum. Aluminum is 3 plus, so after you've done this, you say 3 Faraday, which is this, gives deposit 1 mole, 1 here, then say X Faraday will deposit. So this, we are trying to look for the amount of current that deposited that 1.5 of aluminum, then so deposit 0.056 mole, and so that's then you get X to be equals to 0.167 farad. So this is the amount of electricity that deposited 1.5 gram of aluminum. Now they now say, the question says how many will this same current deposit for copper. Then you come to copper, you write copper is C2 plus, then after you have written that out, you say 2F 2 Faraday, that's this, gives 1 mole, and then 0.167 Faraday, which is this, will deposit X mole. Then you, after you've done the cross multiplication, then you get your X to be 0.08 mole. Now you know the formula for calculating mass, that's mole times molar mass. So 0.083 mole of copper times 64 will give you this. So this is what you actually get. Also, by using the formula, you know, they said according to the question, the quantity of electricity that deposited used is the same for both copper. The quantity of electricity that is used to deposit certain amount of copper and aluminum, they are equal. So you know, you have Q and copper equals to Q aluminum. So you refer back to the formula, which is M over MM equals to Q over NF. Make Q the subject. Then you now say M, since they are equal, so mass of copper times the number of charge on copper times Faraday over molar mass equals to the mass of aluminum, and so on. Then you now see mass of copper, which we are looking for, times 2. This 2 is the number of charge on copper, times 96,500 over 64, that's the molar mass, equals to what? 1.50 times 3 times. We got this right now. So then you are going to look for, make M the subject. So when you make M the subject, you are going to get what 5.34 grams. The third question says 0.1 Faraday of electricity deposited 3.2 grams of copper during electrolysis of an aqueous solution. Then the number of moles of copper that will be deposited by 0.6 Faraday is what? Option. These are the options that were given. So first of all, you have to know the number of charges of that particular substance that is deposited, and in copper it is 2 plus. So then after you've known that it is 2 plus, then you look for the mole, because they said 0.1 Faraday deposit 3.2 grams. So look for the mole of copper that is deposited, and the mole is calculated as mass over molar mass. So when you come down here, say mass over molar mass, 1 mole of copper deposited by 0.1 Farad equals to mass over molar mass, that is equals to 3.2 over 64. So that's 0.05 mole. So then you now do the relations, like you do the proportionality. That's 0.1 Faraday deposits 0.05 mole. That's 0.05 mole. Then 0.6, that is the question. They said how many with 0.6 deposit? That's 0.6 Faraday deposits X mole. Then you now cross multiply. It says 0.1 equals to this, and you're going to get 0.3, which is option D. And also you can use the formula method as well. So when you use formula method, you can also get the same thing, but this time around, you just have to work with the 0.6 Farad that you were given. So you don't really need the other information for that. So that's mass over molar mass equals to quantity of electricity over NF. This N is the number of charge on that substance. So, and remember that Q over F, your Q over F is quantity in Faraday of electricity in Faraday. So mass over molar mass is equals to mole, and you are looking for the mole of copper that will be deposited by 0.6 Faraday. So just come here and say mole equals to 0.6, which is Q over F, which is Q over F, which is Q over F here, 0.6. That's what we're given here, over the number of charge over N. Over N, that's the number of charge, that's 2. So you're going to get your answer directly. So I think the formula still makes the work faster. So also this next question says that how many kilograms of aluminum will be produced by the electrolysis of aluminum triosonitrate 5 in a cell operating for 24 hours at 400 ampere? And then we are given the additional information. Look at the options here, and so you're going to start by looking for the quantity of electricity, because you will need it. That is Q equals IT. Then you convert your time to seconds, so that is 24 times 3600. So then you get 34,560,000 coulombs. And all right, so what next is you have to know the charge. It's not necessary for you to write this because it's CBT, but you just have to know that the charge on aluminum is 3 plus. So then you write out I'm going to use formula this time around. So that is mass over molar mass equals to Q over NF. Then that will be mass, that's what we are looking for, over molar mass 27, it was given here. And then quantity of electricity, we've calculated it here already, that is that. So time over 3, this 3 is from this place, that's the number of charges, so times 96,500, to give you this. Then you convert it to kilogram. Right, so see, this next question says what current in ampere will deposit 5.4 grams of aluminum in 2 hours? So first look at the options that were given here. So use the using formula. You have to know that current will be gotten. You can't get your current when you are not given the quantity of electricity, because quantity of electricity is Q equals IT, and we don't have it, so you have to look for it first. So you write out the formula, that is mass over molar mass equals to quantity of amount of charge over quantity of electricity over what number of charges times Faraday's constant. So when you make it your subject or formula, okay, you can just substitute in your values. Mass is 5.4 as we were given in the question, over molar mass of aluminum is 27 equals to Q over this. And so when you make Q the subject, you are going to get 57,900 coulombs. Then you come back to your I equals to Q over T. Then you convert your time to seconds because we're given in hours, so that will be 2 times 3,600. So we get 8. So the answer should be option D. Alright, so guys, here's another question. What is the quantity of electricity required to deposit 128 gram of copper from molten copper to chloride? Then here are the options we're given. So first of all, you have to know the amount of charges of copper that will be involved. That's 2 electrons of copper. Then you write out the formula. You are being asked to find from the options. You can see that it is coulomb that the unit is, so they are asking for the quantity of electricity. So that will be Q. So that is Q we are looking for. So we have 128 over 64 equals to Q over 2 times. So this is the mass, this formula. Then the mass is 128 as we're given from the question. 128 is 128. Then the molar mass of copper is 64, and so also the number of electricity of charges, that's 2, and then times Faraday. 1 Faraday is 96,500. So then you substitute it into you make Q the subject, then you are going to get this. So that's option D. So alright guys, so here's another one. A current of 0.5 amps flow for 16 minutes 5 seconds and deposit 0.163 gram of a metal X during the electrolysis of an aqueous solution of a salt of the metal. What is the charge on the metal ion? Now we are being asked to find the charge, that is the N. So, and we do not have, before you can get the N, you need Q, and we're given information to get Q. So Q equals to IT. So that's I is 0.5 amps. So what you're just going to do is Q equals 0.5 times, we're given time to be 16 minutes 5 seconds, so convert 16 minutes to seconds and then add it to the 5 seconds. So I'm going to get 16 times 60 plus 5, and then you get your coulomb as this. Then you come back to the formula and substitute your values into it. So you have mass is given as 0.163. So put your mass there, that's 0.163 over 65 equals to 482.5 over N. This N is N you are looking for. So when you make N your subject, you get this, and so you get 1.99, which is approximately 2. So your metal should look like this. Then another question says the silver and copper voltmeter are connected in series. If 5.63 gram of silver is deposited, the mass of copper deposited is what? So these are the options we're given, and these are the additional information. So according to the question, silver and copper are connected in series. So if they are connected in series, whenever metals are connected in series, that means the current does not, the current remains the same. It does not change. If they are in parallel, then they have different current, but if they are in series, the same current moves around it. So that is then you say quantity of current of silver, or quantity of electricity of silver equals quantity of electricity of aluminum. Then remember, you make Q your subject from that formula, so you get this. So then you relate them together. That's mass of silver times mole of number of electricity of silver over number of charges over molar mass equals to this. So because they said Q is equals to Q, so you do that. Then you substitute your values into it. Then you get mass to be what? Of copper deposited to be 1.668, which is approximately 1.67. That's option B.